All right, so you've seen quite a bit of information about more collected data from multiple sites. We're going to talk more about individual sites over multiple years. So we look at some Rutherford information going back to 2013, and this is on the berry weights. And so what we see when we go through these, and a shape that's sort of, you've seen in many of the presentations already, is there's sort of this umbrella-shaped curve. We kind of reach a peak, there's an accumulation point, a peak, and then from that peak we fall. And we go through 2014. Notice, of course, also at the same time, when we're looking at, this is days from the start of veraison. Okay, so you can also see where the peaks are from the time of veraison. So we see that some seasons are definitely longer than other seasons are significantly shorter than other seasons. 2015, and what's interesting about 2015 is how short the season was, both in terms of days post-veraison, but also how rapidly we reached peak, and from that peak we fell. A lot of that was heat-related. 2016, long and steady, kept going long into the season. By now we're getting into days, for example, 60 days post the onset of veraison, called 1 or 2%. 2017, similar little uptick as we went through. Things increased, but definitely a long season. And then, of course, 2018, longer still, at a higher rate as well. So we look at berry rates in Rutherford. What this is showing from a single site is that we maintained a level of weight for a longer period of time from the time of the onset of veraison. That's relatively rare. So what we saw then was that we had a very long season, and we didn't suffer the 2015 event of losing berry weight drastically. So we take that into berry sugar loading, and sugar loading is such a brilliant concept. It's so simple, right? We're talking about the sugar per berry basis. But what we'll see in all of these issues is that when we look only at Brix does not take into effect the sugar per berry. And what happens is, when we go through that, certainly 2014, 2015, is that we might see increases in Brix, even though at the same time we're seeing decreases in per berry levels of sugar. And that's really kind of crazy. The only explanation for that is that we lose water faster than we lose sugar. But in all events, we do lose sugar as we move through the process of ripening. 2016, again, matching very much what the berry size was, long season, long into the 70 days post-veraison. And then 2018, once again, we had berry sugar loading relatively flat, but all the way to 70, 75 days post the onset of veraison. That's pretty rare. Extractable anthocyanins. This is our own unique measurement of anthocyanins through basically a model extraction. It's a relatively non-destructive, meaning that we do not grind everything up in a blender, but we do a model extraction based on what was similar to a production environment. And what we see the extractable anthocyanins in 2015, we did see a decline quite a bit. 16, likely long in season that kept going relatively long into the post-veraison period with beautiful increases. 2017, similar again, just nice long after the period of veraison. We were still accumulating anthocyanins on an extractable basis. In 2018, we did see a significant reduction in total anthocyanins, but how much of that matters is really dependent on the human eye. I'll talk about that later. But then in tabular form, what you notice is that the two numbers that we're going to be looking at, that is the peak berry weight and that is the harvest berry weight. Okay, so when we look at that, the one thing that comes to mind in 2018 for these particular vineyards that we were tracking around 1,500 on this block, and then from the peak anthocyanin level to the harvest anthocyanin level, on a per berry basis, we do see a decline. But that's typical. We see that in most of the systems that we work in. We get down to 215. Remember how we saw the drastic shape of those curves? You can see that we saw was a 20% decline in berry weight from peak to harvest. A lot of that was temperature related. But when you look at this in tabular form, right now it's not perhaps jumping out at you, but when we put it in perspective, you can see how some of the berry weight measurements, as well as less than 1 gram per berry, and then the magic number of 2,000 milligrams per liter of anthocyanins is a very high number. And we really have to go back to 2017. The most similar vintage to that in work here in Rutherford was in 2013, which was a magnificent vintage. So we take a look at 2018, and lo and behold, 2018 in Rutherford tracked very similarly to 2014. But in all events, what's amazing is that in the same block, same vineyard over multiple years, we can have variations. Pardon me. we could have variations in the anthocyanin content upwards of 1,500 ppm, upwards of that's almost a 25 to 35% increase in a per berry basis, a per block basis in a single single vineyard. So when we track the extractable amount of anthocyanins, we do see this bell-shaped curve, as Cecilia was saying, but they all have this. Johnny calls it the umbrella-shaped curve. But when we track that with actual berry sugar loading with the berry weight, we come to this pretty similar conclusion that when we take our sort of axis point here, what we find is that there's a very, very strong correlation between the fresh peak berry weight, the peak berry sugar loading, and the peak extractable anthocyanins. So as a simple and powerful tool that all of us can do, certainly with the Bordeaux varieties, Pinot Noir is a little more destructive when removing berries from the rachis, is that if all we have to do is measure the berry weight when sampling for bricks and just track that. And start sampling earlier than your 20 bricks. Start sampling at 15, 16 bricks and maintain just a log of your overall weight on a per berry basis and count your berries, of course. And then follow that. And when you do that, I think what you're going to see is that you'll start seeing this trend line where you'll see the decrease in your berry weight, and that probably means you're past the peak of anthocyanin accumulation. Now, of course, in order to do that, you need to know that you reach the peak, you have to be beyond your peak. And of course, there are a lot of literature in Bordeaux, France, and other areas in France where you're picking between 7 to 10 days after the peak. So knowing your peak is very important. So when we move into extractability inside the winery, on the left side we have our berry information, which is this column here, which is the peak number at harvest. And then inside the winery is what we have here in terms of what was actually able to extract in the fermenter. And that comes up with a value, in this case, over 94%. That's very high, okay? So when you have 94% of your berry anthocyanin reached in the winery, that's a pretty significant number. That's quite high, very high. Most of the time we see averages around 74%. And 50 to 74% is still relatively a lot of color. But it begs the question about what is a maceration kinetic, meaning what makes the difference between a 75% extraction total versus a 95% extraction total. And if we take a look at those Rutherford numbers that we saw from the berry information I showed you, if we look at the anthocyanin in the fermenter, okay, so there's days post-crush, and we look at our daily increase in anthocyanin, and we see 3 different profiles. 2017, unfortunately, due to the fire, we have some incomplete information. But what you see there clearly is that even though we have 3 different shapes or certainly slopes to the curves, we do approach within 10%, if we look at this number here, 1,000 ppm of malvin triglyceride up to 1,100. That's relatively close. And when we look at the actual tannins in terms of an extraction of the protein precipitated by the Harbison-Adams assay, we see 3 very different curves here as well. So the slope on the 2018 was very slick, the 17 was more moderate, and 2016 very relatively shallow in terms of slope. What that tells you more than anything is that there were 3 maceration protocols employed over 3 different years that affected the amount of tannin extraction. So by that, what we want to show is that when we look at some other 2008 Napa Valley samples, this is fascinating because this is actually the anthocyanin versus the protocol. And if we look at what we're seeing here is a delay in the onset of the actual anthocyanin build. Well, that's the effect of the difference in time of cold soak. Okay, so one basically is 3 days, 4 days, 5 days, etc. So it says basically an extended maceration cold soak trial. What's fascinating about that, and this is not a bad idea in terms of staggering your cold soaks, because this is what we call the theory of the double black diamond. The first time you ski a double black diamond with your friends, you don't all go over the edge at once. You send one person, then you send the next person, then you send the next person. And when you do that, what happens is you get a good indication. So by the time you launch this one, you already have an idea what the other curve is doing. And so when you do that, you realize that even though cold soak periods are relatively different, upwards of 5 days, the relative amount of total anthocyanin in the must was relatively similar. Okay, so what does that tell you? It tells you 2 things. Number one, length of maceration and cold soak is really not necessarily correlated to the actual peak of the anthocyanin in the must. Rather, what it means is basically we will get there if we have enough time. If we look at the tannins, though, tannins are fascinating because tannins require the alcohol and the temperature. Okay, so we're not going to get we're not going to get tannin release During our cold soak period, Anita will tell you a day was that if you go to 25 days, you might get some protein precipitable tannins, but that's really not applicable to the production environment. But the first thing that you see here is the relative uniformity of the slopes of all of the tannin extractions, and that the first thing that comes to mind is uniform temperature. So what that's telling us is that the winery applied a uniform protocol. The only difference was the amount of cold soak time. So the drivers of extraction, they're really well documented. We have time on skins, temperature, alcohol level, and movement. All of the time and temperature affect all the extractions. Alcohol level in particular and temperature affect mainly the tannins. But we see cold maceration producing high amounts of anthocyanin. We see hot maceration producing high amounts of anthocyanin. Anthocyanins are water soluble, therefore they come out both in the aqueous phase as well as the alcohol phase. It's important to remember that perhaps the most important driver that we have is temperature. Okay, so global warming, this was something that really kind of shocked me, was that the 5 warmest years on record. How about that? Yeah, where are we now? Maybe we've got one, this year might be the year that we don't have it. But clearly that the world is warming, and it's happening literally it's happening to all of us, and it's happening in most recent time period. So the anthocyanin formation, we'll talk about it in terms of grape and temperature, and then the degradation is grape and temperature, which Luca talked about quite well, obviously, and then the anthocyanin degradation as juice, as temperature, and then how do we stabilize the anthocyanins when they're as unstable as they are. So this is work that was done that was showing basically the accumulation of anthocyanins in a greenhouse effect at 25 Celsius versus 35 Celsius. And it's staggering, right? So the warmer we are, the less color we produce in the berry. So that's well documented. But what's crazy about it is that when you look at the 25C and you look at the malvidin, what you're seeing here, this is 2 weeks after onset of veraison, 4 weeks and 6 weeks. What you see with the cooler temperatures is you have this big jump from 2 weeks to 4 weeks to 6 weeks, a slight decline, which is what we see. But when we increase our temperature, what happens is not only is the peak much lower, but the accumulation rate is much slower. So the warming temperature does 2 things. One, it reduces the total amount as well as the rate of the amount of the accumulation. But we always talk about anthocyanins, plural, and the reason we do is because we're talking about a series of anthocyanins from some of the relatively smaller players, cyanidin, petunidin, delphinidin. But you can see that the temperature effect on these other groups of anthocyanins is very significant as well. So the temperature is not only going to affect the total amount, but it's going to affect the individual species of the anthocyanins, individual basis as well. And so probably one of those varieties, one of those anthocyanins is probably the canary in the coal mine. That's going to tell us that it'll be more affected by the heat, increased temperatures. And what Luca showed you with the berry temperatures being higher than the ambient temperature, so that tells us that heat significance in terms of accumulation is unbelievably critical. The next thing you have to realize is that when we take a look at it from terms of the degradation of the anthocyanin once it's liberated, okay, so now that we have it in solution, this was work done on juice, on Merlot and Ruby Cabernet juice in Australia. And so we go from 5 centigrade, basically 41 degrees Fahrenheit to 25, 77, upwards of 35. And what that tells us is that you can see that the rate of fall, we can refrigerate it, we can maintain our color, but as we start increasing our temperature we lose our anthocyanins so unbelievably quickly. And that's very important because most of our cellars are probably around the 14, 15 centigrade range, so we know that we are probably in this area. And sure enough, in the winery, we see the anthocyanins decline rapidly. If we take a look at where we stand with the free anthocyanins, with Cabernet samples from last year, the same slide we looked at, but look just at this is basically the 15 days, we see that you have a massive build on anthocyanins reaching a peak value. At the same time, the stabilization effect, which is the polymerization of one molecule of tannins binding with one molecule of the free anthocyanins, creating our stable form of the anthocyanin. But during primary fermentation, we're here at 150 ppm versus upwards of 1,200 ppm of our free anthocyanins. So we're still about 13% of the total amount. But when we look at the élevage period, when you look down to about 120 days or more, what's crazy about the anthocyanin levels from our peak maceration amounts, we literally drop upwards of 50% of our available anthocyanin, our free anthocyanin, in the first 4 months of the wine's life. So the decay of the anthocyanins are so unbelievably rapid that our stability is our binding. So we've gone from being 13% of our available anthocyanins in the bound form upwards of, let's say we're at 250 versus 600, so now we're up to 45%. So what that tells us is that the stabilization of the anthocyanin is really what's going to save our anthocyanins over time. So now the good news. The good news is that the human eye can only see between 10 and 20% of the available anthocyanins. If we could see more than that, then Pinot Noir would look like Petite Syrah. Okay, so we have an overabundance of anthocyanins, luckily, and the human eye only wants to see so many. So with global wine warming, we do know the warming conditions are going to reduce the total anthocyanin creation as well as its rate of creation. Then relatively stable in the plant tissue, obviously what you saw with Luca is that sunburn has tremendous degradation effect on anthocyanins. But once they're inside the plant, they're relatively stable. So if we reach our peak and we lose 10% by the time we harvest, that's really not big considering how much we're going to lose in the winery. Then the anthocyanin degradation in juice and wine increases with time, 50% or more in the first 100 days. And then they also increase the degradation at higher temperatures, which makes sense. It's kinetic energy. However, the stabilization increases with temperature. So what that's telling us is that we know that from the work that we've done with flash détente, you wouldn't believe that coming out of a flash détente machine within a 2-hour period, you would have a lot of bound anthocyanins. Well, the reality is they come out looking like 21-day macerations. So we know that even in the presence, without the presence of alcohol, they would liberate a tremendous amount of tannin at heat with the anthocyanin present, create a lot of the stable form of the anthocyanin. It's pretty remarkable when you think about it. So with that, I can tell you that we have, Johnny and I are both here. If you have any questions, we'd be happy to answer them.
Anybody have questions for Scott?
Hey, Scott, thank you for that. I was wondering, so you were saying despite that, the human eye only sees a certain part of it. I mean, doesn't anthocyanin play a huge part in the mouthfeel?
Does anthocyanin play a large amount in the mouthfeel? What happens to that tannin, that's a fascinating question because there's a lot of work both on the polymeric pigment having a sensory effect. So that is not related to the optical effect. So the answer to that is yes, the polymeric pigment, when it's attached to the tannin is no longer reactive to your salivary protein. However, it's present. So it has that ball bearing, that viscosity effect that is so important. But from a purely the optical perspective, our eyes see about 10 to 20%. So always have to remember about macerations as we're talking about a portion, of the actual amount of the grape. We go from 2,000 pounds of grapes, and we become 1,300 pounds of wine in a 2-week period. Okay, from that, of the anthocyanin levels that we have, we're lucky to be able to see a good maceration might liberate 70% of those anthocyanins in our wine. That 70% is going to decay 50% in the next 3 months. So when you look at it, we're looking at partial extractions of partial extraction. Then the human eye sees a portion of what we actually have in our wine at the end of it. But that small, tiny portion is enough for wine to be wine.